Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. So now let's solve this paper for Mechanics M1 paper. This is October-November 2025, variant 43. Let's read the first question. It is a kinematics question, constant acceleration, graph of velocity against time is given. The diagram shows the VT graph for the motion of an athlete. The athlete runs in straight line from point A to B, run back to point A and finishes at point B. And then the graph consists of 4 straight line segments. Find the deceleration of the athlete 7 seconds after leaving A. So 7 seconds after leaving A, all along this line, keep in mind it's a straight line, so acceleration is constant. Whether they're asking at 5, asking at 6, asking at 7, asking at 11, between 5 and 15, the acceleration or deceleration, because it's negative, it's constant. Find the total distance traveled by the athlete. If they were asking for displacement, this would be taken as positive, this would be taken as positive, this one would be taken as negative. But since they're asking for the distance, ignore the negative sign and take it as positive also. Now the very first thing is that we have 5, 8, we have 10, 0, and the gradient is coming out to be negative 1.6. Deceleration, the word has a negative connotation. It means that it's slowing down, it's 1.6. Now look at all these triangles. I mean, it's very strange that they have given the exact 3 triangles like this. So this is 0 till 10, this is 10 till 20, 20 till 30, maximum value 8, minimum value negative 8. So the area is the same. Half into base into height, that is 40, 40 times 3, that is 120 meters, too easy. Second question. The engine of a motorcycle can generate a maximum power of this much. The mass of the motorcycle is 400. Total resistance is CV Newton, where V is the motorcyclist speed and C is a constant. The motorcyclist travels along a straight horizontal road under maximum engine power. When the motorcyclist speed is 35, his acceleration is this much. Show that C is 80. The motorcyclist now travels up a straight hill under maximum engine power. The hill makes an angle of this much, and find the steady speed at which the motorcyclist travels up the hill. Nice question. First, it's horizontal. Forward force, that is power over velocity or speed at that instant. The resistive force, that is 35C, because the speed is 35. That's used over here, that's used over here. Let me just highlight this. So this 35 is used here, 35 is used over here, that is this V. And the acceleration is 0.5 meter per second square. So now you would say the forward force minus the resistive force is mass into acceleration. This is application of F is equals to ma. Resultant force is mass into acceleration. You find the value of C, which is 80. That's an exact value. No rounding off. Now it's going up the hill. Now first thing first, sine of theta is 3 over 20. Sine inverse of 3 over 20 means that is the angle. So if I write theta, that is sine inverse of 3 over 20. In other words, sine 30 is 3 over 20. No need to use the calculator as such. It's moving at steady speed, therefore acceleration is 0. That means the forward force should equal the weight component downwards, mg sine theta, and this resistive force. So 105,000 divided by V minus this is mass into acceleration. And then let's multiply throughout by V, simplify, use the quadratic formula, and then you get the answer 32.7. Of course, you will discard the negative sign. The next question. A block of mass 4 kg is pulled along a rough horizontal road by a constant force of magnitude 25 at an angle of 36, just like the questions that have come earlier, that the force is acting at a particular angle. The block moves in a straight line passing through 2 points A and B. AB is this much, coefficient of friction is this much. Find the work done against friction. The speed of the block at A is 7. Use an energy method. Find the speed of the block at B. So 3 and 4 is 7 marks. So it's now work energy principle. First thing first, I have drawn a diagram. I have labeled R acting upwards, mg acting downwards, 25 cos 36 over here, 25 sin 36 over here. R plus this equals to this. R plus this equals to this. So I find the value of R. I multiply it with 0.4. I find the value of F max. So F max is this much over here. Now work done against friction, that should be F max into the distance that it moves. So this thing is F max again, and this is the distance that it moves, which is 120 meter, which is written over here. That comes out to be this thing. If we use it for further calculation, use the unrounded value. For this part, the answer has to be given correct to 3SF. Now use that famous equation, work done by external force. Sometimes it's an external force, sometimes it's an engine. Work done by external force, that is the weight component into the distance. Change in potential is 0 because it's a horizontal surface. Change in kinetic, half into m. Initial speed is 7, final speed is more, half into m into v square minus 7 square, plus work done against friction, that's right over here, and you find the value of v. So of course, all the basic working that you have to show. So show all working in order to gain full marks. And that is what I'm preparing you for. That is like an A star or an A. Okay, let's move on. So let me just move over here and just start with the question right away. So now it says the particle P moves in a straight line, and at time t seconds after passing through a point O on the line, the displacement is given by such and such. It's a cubic equation. Find the value of S when P has its minimum velocity. Also find the speed of P at this instant for 6 marks. Now this is all calculus based, usually P1 based. So S differentiate, you get V. So we know that ds by dt is equals to V and dv by dt equals to A. So this one is ds by dt, this is dv by dt. So first of all, you need all three calculated, evaluated. So now minimum velocity when dv by dt is 0. Minimum of anything, of any quantity, its derivative equal to 0. If they ask about minimum maximum displacement, displacement derivative equals to 0. Minimum or maximum velocity, derivative of velocity equals to 0. Minimum or maximum acceleration, derivative of acceleration equals to 0. So now when we equate it to 0, we find t is equals to 10 seconds. That is good. Let me highlight this thing. That's too thin, like this. So now once this is done, find the value of S. Now plug in the value of the S equation, that is negative. It's moving in the other direction. It has moved. And find the velocity, that is also negative. Since it's asking for speed, take the absolute value, take the positive value for speed because it's just the magnitude. The next one, find the acceleration of P at the instant when the direction of motion changes. Direction of motion changes when V equals to 0. So now that's the quadratic equation equal to 0. Get rid of all these decimals and you get this thing. Your choice to do middle term factorization, your choice to use quadratic formula, and there is a negative thing, reject it. So reject the negative thing and accept this thing. Now t is 23 is exact. What else is there? Find the acceleration. So find the acceleration, plug it in over here and you get this answer. That is also exact. So that was a nice question, a tough one in the sense the working has to be super solid. The next one, the pulley question. Now it says particles A and B of masses 2 kg and 6 kg. Now make a habit of drawing some things over here, the force diagram. This is 6G, this is tension, this is the same rope, same string, that's the tension, that is 2G. And now what is happening, let's have a look. I haven't labeled the acceleration as yet. Particles A and B of masses 2 and 6 are attached to the ends of a light and extensible string. If they are just let loose, the heavier one will go down and the lighter one will go up, right? But that's not the case over here. The string passes over a smooth fixed pulley and the particles hang vertically below the pulley. Both particles are initially held at rest and the height of 3.2 meters above the ground. Particle A is projected vertically downward with a speed of 1.2. So now particle A is projected downwards. So acceleration is this way, acceleration is this way. Yes, it will come out to be negative. Why will it come out to be negative? Because this is lighter. It's forcefully pushed in this direction. So it will slow down and then it would turn around and move up. That's the scenario. That is what you have to envision. So now 2G minus tension is 2A. That is the first equation. and t minus 6g is 6a, therefore a comes out to be negative. That is what you are getting. So a is negative 5 meter per second square. The tension, plug in any one of these two equations, that comes out to be 30 Newton. That thing is done. So now the next one, what is it asking? Find the tension, and this thing, that is for 4 marks. Now over here, part B, I have done it on that side, so just bear with that. In the subsequent motion, it says, in the subsequent motion, A does not hit the ground and neither particle reaches the pulley. When B hits the ground, it does not rebound. Find the time that B has in motion. Find the distance between the lowest and the highest point that A reaches. Now a very, very elaborate question. Now 4 marks for this. Then there is 4 mark over here and 2 mark over here. The marks are a bit lesser, but yes, we have to do what we have to do. So now the first thing, what I'm doing is this thing. This is method 1 that I've written. U is 1.2. That is, I have evaluated this thing. It was pushed with the speed, right? It says over here, U is 1.2. And acceleration is -5. Final velocity is 0. Let me find the time that it takes, 0.24 seconds. Let me find the distance that it travels, that is 0.144. That means it was 3.2 meters above the ground. It would just go down a bit. It would, the velocity would drop to 0, and then it would turn around. What is happening to particle B at this instant? Initial velocity is 0 and acceleration is 5. So now it is above the ground, because initially if this is moving 0.144 down, this is moving 0.144 up. This is how high it is above the ground. So now over here, v square is u square plus 2as. I'm finding the speed that this particle possesses. Okay. So now over here, that is the speed of the system, because now both the particles are connected by a light inextensible string. So this is connected particles. They have common acceleration and they have one string, one tension, unless and until the string breaks down or some particle hits the ground. Keep that in mind. So now let me use this thing. S is equals to ut plus half at square. So that is the height that it has reached, and final velocity is 0, and I'm calculating the time, 1.156 seconds. So this is moving in this direction, and then the thing is moving in the upwards direction. That is how this has gone. So now the distance, the total time taken is 1.40 seconds. They are asking, find the time B is in motion. Now there is another perspective. That perspective is this. That is called method of displacement. Look at the live stream that I've taught. I have gone over this thing. When such is the scenario that if this particle B that was going up and then all the way it will move down. So now that is called method of displacement. We take initial velocity to be positive, acceleration to be negative, S to be negative, because we are talking about B hitting the ground. So now B will move up a bit and then it will drop all the way to the ground. Okay, so that is the scenario. So basically, if I draw a diagram like this, this is like the cliff question. So this is like particle B. It's moving up and then it's moving all the way down. This was 0.144 and then it's moving down 0.144 plus 3.2. So this is method 1 that we have used. But if we are using method of displacement, I'll take velocity to be positive, acceleration to be negative because it's making a turnaround, and displacement to be negative. So displacement will be from here. So displacement will be negative 3.2. So displacement is negative 3.2. Initial velocity is 1.2. This is a into t square. So now over here, when I calculate t, I get exact same thing, which is 1.40 seconds. This is in steps. Method 1, this is in step. This is going down. And this is B was going up. And then now B is going down. That is how this thing is happening. The total answer, the final answer is the same. Now here comes the important part, and for that we need the method one also. Find the distance between the lowest and the highest point that A reaches. So now first of all, A went down this many meters. We already did the calculation. And then that is this one, the red part. So now let me just get this thing. Okay. So now that is this part, that A went down 0.14. Now A went up 0.144 plus 3.2 till B hits the ground. So now first they were at the same level. They went down 0.144. This went up 0.144. Now what is happening, that it will first go 0.144 up and then 3.2 up because B will hit the ground. Correct? Part 3. Now A behaves as a free particle. Why? Because the string is slack. String is slack. B does not rebound and it behaves as a free particle, freely moving under gravity. That is what we mean by free particle. So U is this value, which again was calculated over here. So now all these parts are needed. So yes, a method of displacement is a nice one for that part, but for this part, for 4 marks, again you have to calculate some of the terms from there. And acceleration is -10, V is equals to 0, S comes out to be this much. So now the total distance between the lowest and the highest point. So it's not about how much it has traveled, it's about the lowest and the highest point. It went down 0.144, it moved 3.2 up till B hits the ground, and then further on it moves 1.6179. That is the final answer. Yes, that was one tough question. Now let's look at question number 6. So question number 6, it says a particle of mass m kg and a particle q of mass 2 kg are free to move on smooth horizontal plane. They are moving directly towards each other. So if I make P move to the right, let me give this a positive sign. Therefore, Q should be given a negative sign. In the calculation, that is negative. So let me just highlight this thing over here. That is P. That is P. This is Q. This is Q. So now let's focus over here. So therefore, let me read it further. They are moving directly towards each other. These are the velocities. These are the speeds. P and Q collide. Direction of motion of each particle is reversed. Now P will move in this direction. Q will move in this direction. P in this direction. Q in this direction. Immediately after the collision of P, the speed of P is U over 3. That's 1/3 U. Find in terms of M and U an expression for the velocity of Q after the collision, and hence show that M is greater than 4.5. M is greater than 4.5. Okay, nice question. So now momentum before, momentum after collision is the same. M into U, 2 into -3 U. This is M into -1/3 U, and this is 2 into V. Simplify, 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 and we get this thing. V is this much. Okay. So now expression for velocity of Q, that is this thing. So now let me just highlight this. That is the velocity equation. Now it says, show that M is greater than 4.5. Why? We know that this velocity is positive because now it's moving in this direction. We are taking velocity to be positive. And it's moving, so of course it has to be positive. So therefore 2/3 m minus 3 is greater than 0, 2/3 m is greater than 3, therefore m is greater than 9 over 2 or 4.5. So therefore this has to be a positive value. So 2/3 m should be greater than 3. That is the logic. So very, very nice question again. So in mechanics, 1 or 2 parts are such which are out of the box. Now it says Q subsequently hits a vertical wall which is perpendicular to the direction of motion of Q. The speed of Q after impact with the wall is a quarter of the speed before the impact. The speed after impact, let me highlight this. The speed after impact with the wall is a quarter of the speed before the impact. There are no further collisions between P and Q. This is also important. There are no further collisions. Given that M is an integer, determine the largest possible value of M for 4 marks. And yes, that is the main working. So now velocity of Q is 1/4 of the previous velocity. This is the velocity of q, and now it's 1/4 of that. Okay. No further collision means now after rebounding, q cannot overtake p, because now p is moving in this direction. It went, hit a wall, rebounded with 1/4 of the velocity. That means either they would be moving like equal to one another, parallel, side by side, yani that one would be forward, this one would be backward, and the distance between remains the same, or this velocity should be lesser. So either Vp is greater than or equal to Vq, or Vq is lesser than or equal to Vp. So now if I use this one, this is 1/4 u, 2/3 m minus 3 lesser than or equal to 1/3 of u. Cancel out the u, do the working, do the math. M is lesser than or equal to 6.5. Also from part 1, now this is a beautiful correlation. Also from part 1, m is greater than 4.5. So it's moving in this direction, it's moving in this direction. There are two possible values, that is 5 and 6, but they have asked us largest possible value. So out of these two, which is the largest integer value? That is 6. So another out of the box question. Question number 7, that was the easy one. Yes, it came later, but that was the easy one. So it's giving you relaxation till the end of the exam. A particle P of mass 6 kg lies on a rough plane. So that is 6 kg on a rough plane. Acute angle theta. Horizontal force of magnitude 12 Newton. Horizontal force that needs to be resolved along the plane perpendicular to the plane. This is the adjacent. Adjacent is associated with cos. So this is 12 cos theta based upon this. Why is this theta? Because of alternate angle. This has to be 12 sine theta. If 12 is towards the particle, the two components are towards the particle. The weight component 6 kg, that is mg sine theta down the plane, mg cos theta perpendicular to the plane, r is acting up. P is in equilibrium and on the point of sliding down, so therefore friction is up. Therefore F max is up. Okay, show that mu is this thing. So now the very first thing that we need to do is to evaluate R, or get an expression for R. So R is this plus this. R is this plus this. M is 6g cos theta plus 12 sine theta. F max is mu R. Write it down. So 6g is written as 60. 12 is written as 12. I have taken 12 common out. 12 mu. About to slide down, friction is up. So therefore mg sine theta, that is 6g sine theta. This is 12 cos theta. That is going up. F max is going up. So about to slide down, F max up the plane. 12 cos theta plus F max is 6g sine theta. 12 cos theta plus 12 mu sine theta plus 5 cos theta is 60 sine theta. Again take common, divide, and then you get this beautiful answer, which is over here, mu equals to this thing. So that is right over here, mu equals to this thing. Okay, so that is how this thing is obtained. So it's all symbolic. Now hence find the set of possible values of theta. Again a nice question. First of all, now divide numerator and denominator by cos. So this is like the knowledge of P1, P3, trig, identity, in which you have to prove something. So when I divide by this thing, so numerator divide by cos, denominator divide by cos. Now look at the working. 5 sine over cos is 5 tan, cos over cos is 1, sine over cos is tan, 5 cos over cos is 5. And then you have proven this. That's a set of possible values. It's not done yet. That is mu. So now we know that mu is always a positive value. There is no limitation of mu except it's positive. 5t minus 1 over t plus 5 is greater than 0. 5t minus 1 is greater than 0. T is greater than 0. What is t? T is tangent of theta. So now remember, t is tangent of theta is greater than 1 over 5. Theta is tan inverse 1 over 5, which is 11.3 degrees. Now mu greater than 0 can be written as this. Mu lies between 0 and infinity. We also know that tangent of 0 is 0. We know that tangent of 90 is infinity. Therefore 90 is tan inverse of infinity, correct? So now how much can it go? We know that the maximum has to be infinity, because tangent of theta, mu is greater than 0. and tangent of 90 degrees is infinity. So therefore, it's between 11.3 and this thing. Got the idea? So tangent of theta is greater than 1 over 5. Tangent of theta has to be lesser than infinity. Theta is lesser than tan inverse of infinity, that is 90 degrees. And of course, you know from common sense that if you stand something very vertically like this and there is a particle on it, any which way the particle will definitely fall. So 90 degrees is definitely out of the question. That is the final answer. And I think that completes the paper. That is October-November 2025, variant 43. This is M1. Stay tuned for more papers on P3 that's coming up very soon. Take care.